Okay, so we're at just about at the top of the hour, and we'll get our December 2020 Blockchain at UBC Research Talk underway very shortly. I'm Victoria Lemieux, co-lead of Blockchain at UBC, and I'll do introductions of our speakers shortly. So just give it a minute before the recording officially starts. And I see that there are participants joining us now. So yeah, we're at the top of the hour. So why don't we get going now? So it's my great pleasure to introduce you to two speakers who will be talking about applying blockchain to healthcare with Ethereum, decentralized identity, and peer-to-peer databases. So Chris Ware is an Australian-based technology entrepreneur who's led the development of a decentralized peer-to-peer data storage framework with his company Verida. He previously co-founded Community Data Solutions, providing secure customer relations management solutions for not-for-profit organizations and government, growing the company to 150 customers across Australia. Ray Ng, MD, was born a polymath and entrepreneur. Physician by day, avid technology entrepreneur, coder and blockchain developer by night. MD with board certification and licensure in Canada and US. Ray, you're making us all feel like underachievers here. Ray now runs the COVID-19 assessment site in Vancouver, Canada. In his most recent venture as co-founder of cybersecurity company Securable.io, Ray focused on assisting biotechnology, health informatics, and enterprise executives build and maintain strong security protocols while achieving the highest risk management levels. Securable.io was acquired in October 2017. After this sale, Ray returned to his roots on the west coast of Canada to refocus on his medical practice and study mindfulness, meditation, and other holistic forms of wellness that complement his board certification in integrative medicine. So welcome to you both. Both of you really accomplished individuals, and we're really privileged and looking forward to your presentation today on this initiative. So over to you. I'm not sure who's going to be leading. So over to you, Chris and Ray.
Thank you very much, Vicky. Appreciate that introduction. Ray and I are going to sort of share the speaker today. So just to expand a little bit on what Vicky was saying. So my background is obviously in technology, and I previously had a company that was providing database solutions for nonprofit organizations, and we had a lot of clients that had very confidential data, very sensitive information that was being captured and held on behalf of these patients. And through, I guess, some of the learnings there and some of the recent, I guess, events or more recent events around Cambridge Analytica hacks and this growing trend around privacy, GDPR in Europe, I personally decided that I wanted to work really hard on finding a way to allow people to own their own data and to do this in a way that gave the individual consent over their data, allowed it to be encrypted, and also ensured that it could be shared consensually with third parties. And the advent of blockchain technology is a really interesting development in this particular space, but there's a lot of issues with blockchain technology. There's limited storage and space, and there's performance issues as well. So I personally spend a lot of time doing R&D around how do you look at existing database solutions and how do you look at I guess blockchain technologies and how you try and bring those two worlds together and overlay that with decentralized web standards that are currently emerging. And so through that process, I founded Verida, which is, I guess, a core technology company developing those technologies. And then through that process is how I came into contact and started to collaborate with Ray. And through our collaboration with other team members, we've formed the Ikigai network around healthcare and applying this technology in a healthcare context, which is really exciting. So I'll hand over to Ray to provide a bit more of an introduction on his background.
Yeah, thanks, Chris. Thanks for having us, Vicky. This is very exciting. Yeah, I don't know who writes those bios. I sure didn't, but it is flattering. So let's see where to start. I'm currently practicing as a family physician here in British Columbia, Canada. Made my way throughout the US, throughout Canada as well. And I guess just to put it into context, as it relates to this talk, Chris and I met in an open source world, actually. We met on Discord, for those of you guys that know. And so, this was just around, if not just pre-COVID, actually. And, everyone thinks and assumes that, COVID broke the healthcare system, COVID-19. But in fact, anyone in the space knows it was broken long before that. This was kind of the, that wedge that just opened that door far open. And, as some quotes out there say, when the tide goes out, it, leaves you seeing who doesn't have their shorts on. So it was kind of one of those moments in which we realized that something needs to be done. It should have been done a decade ago, but yeah. And so, some of the problems that Chris will be talking about and how we've sort of partnered up and how we met and how this project moves forward has a lot to do with what we would call sovereign data. I believe that, and we all know that pendulums swing back and forth, the tide comes in and out, the sun circles around the globe. And in what we see with centralized data and the custody of data, we've all become very comfortable having other folks custody our data, whether it's healthcare data, social media data, profile accounts, usernames, passwords. And I think where Chris and this talk will move towards is how blockchain gives us back that control, what we call sovereign data, sovereign identity, and how that ultimately led to this talk today as well, which we like to call sovereign health and the open health movement. So you're on mute there, Chris.
Yeah, rookie mistake. Thanks, Ray. I appreciate that. Yeah, basically, just to give you an overview of what we're going to go through on this talk. So obviously, we're focusing on decentralized databases and public blockchain and how we're bringing those two technologies together and applying it into the healthcare space. There's an important question of why now. I think there's been attempts to do this sort of stuff in the past. There's I guess a growing movement both in the technology world and the health world, and it's important to probably understand the context of where we've come from and where we're kind of going. And then the exciting bit, we're going to actually go through and do a demonstration. So bear with Ray and I as we kind of tag team sharing screens on Zoom and actually show moving data around in this decentralized, this decentralized system. I'm then going to dive into some of the technology and talk about how some of this actually works at a higher level, which is obviously an opportunity for people. If you are a bit technical, you can ask some questions in the Q&A section of Zoom. And then Ray's going to put his healthcare hat on and really talk about what the future looks like in healthcare and applying this technology in healthcare and where we see this technology heading in the next 2, 5, and 10 years. And then we'll open up for more questions at the end. So over to you, Ray.
Yeah. So, this question of why now, and, I alluded to it earlier, is that actually it should have been already, but we find ourselves in the middle of a pandemic right now. And, when the WHO declared, a global pandemic back in March, here in Canada and elsewhere, we had no systems in place. We had no contact tracing, no assessment sites, no user accessible and simple interfaces to move around results and data, no way to reach out to large numbers of patients. And so, many of the clinics that we're operating out here in Canada and elsewhere, a lot of the patient panels have 1,000 plus, sometimes 2,000 patients on a patient roster. And, we found ourselves in a space where we couldn't, send out notifications and messages appropriately to let them know, don't come in, to the clinic here. This is, pre all guidelines on quarantine and social isolation and such. And so, we had an inability, just as an example, to retrieve results for our COVID-19 testing. So I've been working for quite some time now in a COVID-19 assessment site here in Ladner. And, in the very beginning, depending on which system you used, you had to have administrative access to access those test results for the hundreds or thousands of patients you're seeing. And sometimes that would be on a single computer in a single hospital, in the lower mainland somewhere. I won't name where, and you'd have to head over there, or go through various telephone calls and access controls to get a hold of certain results so that you could actually reach out and provide those to the people that needed that. And so I think, and now we actually find ourselves in a situation where, even things like counseling for quarantine measures, mental health counseling for families in distress. In the beginning, it was just telephone calls. And we had various folks try to stay on top of that, to get the information out timely, appropriately, accurately, provide instructions as needed. And it all became very, I guess you can say, complex. And it still is. It's a logistical challenge that we all face. And so where that kind of led us to was we asked, we would email the higher ups up top for a solution, like, help us code this out, or help us make that, or can you set up some centralized system, as we often ask for, to create this. But very quickly we found that a lot of these solutions just had to be created by the individuals that needed it on the ground level, sort of a ground up or bottom up approach. And so simplistic things like implementation of AI and cognitive services for language translation, so that our non-native English speakers, such as my parents or others who speak Korean or Hindi or Chinese, could receive a lot of these instructions in their native language. So that was just one simple example, but also just decentralizing access control and user authentication, so that at a click of a button, a physician could send the results over to a patient, and then the patient could send that back or to another physician. And what we found very quickly was that the physicians and the patients didn't quite have the tools to navigate the system the way that they would have liked. The current state of things is, I would like that folks wouldn't have to come into my clinic or our clinics and ask for a CD or a DVD or a manila folder of their medical records. And it's setting up an appointment and maybe spending a half day out of their work day to come in and do that. It would have been so much more efficient, user-friendly, if the physician could just connect to one of these public networks that would be global, at its base layer and permissionless, such that folks wouldn't really have to plug into one of these megacorps, whether it's like the big top four social media and search firms that we know, or one of the big top firms on software vendors for electronic medical records, for example. And so the way that we saw that was basically what you would call, and Chris will get into it, is Web 3. Web 2 is what we're all used to now, single sign-on with our favorite online service. But Web 3 is more community owned, community governed. You own your own data. And so in the blockchain and cryptocurrency space, you might have heard of by now something called DeFi, or decentralized finance. That was sort of one of the major applications of blockchain and Ethereum network and ecosystem that actually is finding use cases and tremendous experimentation from a software side, and also huge liquidity pools from a capital standpoint, to the tune of billions of dollars. And so where we saw the next practical application of Web3 as it relates to, you and I, all of our patients, is what we would call open health, or the open health movement, which is, in our opinion, far bigger than DeFi because it affects us personally. And also, just as a percentage of GDP expenditure, healthcare is just a gigantic wedge of that in all of North America, but globally. And so, that transition from traditional finance to decentralized finance, we see the analogous version of that from centralized healthcare and healthcare data management, and how that even correlates to clinical trials and research, to a decentralized open health movement, or open health form of that, which is essentially, that permissionless network in which anyone can plug into without requesting permission, and then gaining access to data and such. So, yeah, that's sort of a high level overview, and I'll pass it back to you there, Chris.
Yeah, thanks, Ray. Exactly right. So I think the key takeaway there is that we are transitioning from centralized systems and controls where other people own our data, and fundamentally we're creating this new future where we can take back ownership of our data, obtain benefits from that, and because we can control and share that the aim is to, obviously get better clinical outcomes for patients and improve the quality of care, and also open up new business models, because when people own their own data, they can do different things with it that's not possible when that data is locked away and others are exploiting that and the value that has. So we're now going to tick across to doing a demo. So we have here a vault, which we're going to talk through in a minute, which is where a patient can own their own data. So it's a decentralized solution. As we touched on, we're using Ethereum as the blockchain of choice. And what we're going to do is walk through the process of a patient being seen by a doctor, that doctor creating a case note, that case note then being sent to the patient into their vault. And then the next step is the patient going and seeing a different patient, the patient going and seeing a different doctor, and that other doctor is using a different system. And then we share that patient record to that second doctor on that second system. So trying to demonstrate this truly decentralized sort of peer-to-peer solution where the patient owns their data and passes that between different doctors. So bear with us while we do this. We're going to tag team Ray and I on Zoom, because we're going to try and show you the different screens and how this would actually work. So I'll hand it over to you, Ray, to kickstart the process.
Yeah, sure. And, just to preface this, what's important about, a network, a blockchain system like Ethereum and, a couple others out there that are that we like very much, is that these are open source communities, as is the Ikigai network. And, how we envision this actually rolling out is that any system can plug in. So it could be a telemedicine, platform. It could be a electronic medical record platform. Could be an AI data analytics platform. Ultimately, what it is it just moves from that centralized side of the pendulum back to individual ownership with consent. So that, moving forward, should you decide that you want to, custody your own, whether it's digital assets, medical records, user identities, passwords and logins, you're able to do that in a simple way. Pretty much with the click of a button, we do see, and this is what we're going to show, is that any system can just plug right into it and then provide, I guess you could call customer service for patients, which is long overdue. So yeah, I'll go ahead and jump into the my screen share here and demo it. Okay. Okay. So what you see on my screen here is basically just two views. This is called Care Protocol, but actually it can be any platform for physicians and patients to interact through televideo, telemedicine, group yoga sessions, mindfulness meditation, en masse in large groups, EMR systems in which there's patients and such seeing their doctor on there or booking appointments. And so, on the left side, if a patient here were to just come in, they want to book an appointment, they'll just go through the whole steps that everyone's familiar with, book an appointment, and then actually just launch into, and I won't launch it now, but a televideo platform, and any practitioner can sign in. Now, what's going to be demonstrated today is on the physician side. And so what you can see on the physician side here is this is basically just me as a physician doing what I would normally do. I have my list of patients. I can add new patients. I can click on an overview to see who I'm seeing for today's appointments, which, I've booked today off, which is great. And then you have charts. And the charts is sort of where it's a black box for most people. It's like, what is this medical data? Should we move it around? And what's the value in it? Why does the patient need to have access to that? Do they even want to have it? It's kind of like the difference between a bank, holding all of your money and, maybe in a lockdown or you can't get into the bank, or it's a weekend, or maybe it's Friday after 6 p.m. or, a Sunday, you can't access your funds. And so it'd be nice if you had a little bit of both worlds, a little bit of centralized, a little bit of decentralized. We call it a hybrid model where you can actually bridge or CFI to DeFi, centralized to decentralized. And this is what we would see as a bridge to all systems. And so if you were to go to a list of patients here, and don't worry, this is a demo site in which all patient data was created so that it's available for demo. And so just as an example, what we would do here is we would add what we call an encounter. Pretty basic stuff, right? Birthday, who's the provider, what type of visit are you doing? And then we're just going to enter a note here. And so, this is going to be a 22, for the sake of time, pre-populate, 22-year-old female, past medical history of gastroesophageal reflux disease, has had 2 episodes of upper GI bleed, and requires quite a bit of care. Transfusions of blood, drinks a little bit more than should be drank, and has what we would consider potentially something called varices. We can put it here. Let's take a look here. Yeah, so we can call it. All right, and so we're going to save this here. We have a bit of a plan. We're going to use an octreotide drip here, and this is the important part. As we all know, referrals can take quite a long time. It moves through fax machines for the most part. There are individuals and teams of individuals on the receiving end that receive the fax, review it, pass it to the doctor, pass it back, fax it back to the primary care provider. And then we'll set up an appointment. It might take a few months. So I'm going to go ahead and submit this note here. And once that's submitted, we should be able to just view it like we normally would. We're going to view the encounters. We're going to view the note. Yep, it's all there. So this is where things kind of get a little bit interesting. Normally, if you were just in one server or have one that was not a decentralized permissionless network like Ethereum, that'd be it. I would have to invite you to join this system. You'd have to create an account in this particular system. It'd have to somehow cross borders, which we all know Ethereum is borderless, and unstoppable code. As what they call it. It's censorship resistant. It's immutable as well, and it's encrypted, hashed. So what we're going to do now is I'm going to connect to what we call Ikigai network, which is basically this decentralized system, and it's going to pop up this. I'm going to pass it over to Chris if you want to narrate what's going on here. I'll keep my screen on, though.
Yes, thanks, Race. Yeah, thanks, Ray. So what's actually happening here is Ray has clicked on the Connect to Ikigai button, and it's popping up with MetaMask. So if you're familiar with Ethereum at all, MetaMask sits in your browser and it holds your private key to your Ethereum account. And so if Ray clicks next, that will connect this particular application to MetaMask, which allows us to then do the next step. So if Ray clicks connect.
And I'm going to highlight this. When physicians move around notes and documents, we're signing prescriptions, it's essentially our authority is the signature. And typically you've seen it on the bottom of a prescription pad. What this is and what you see here is what you would call a digital signature. It's a hashed signature on the Ethereum blockchain. So this is how we verify ourselves in how we see the future. Actually, it's here now. So I would say today, we're going to connect now. So this is our new signature.
Yeah, so if you click connect there, so what's now happened is a message has been signed by that Ethereum address. And because that message has been signed, it's then created a unique piece of entropy that is used to generate private encryption keys just for this particular app. So what's going on really is that Ethereum key can be used to create lots of different private keys for different applications. So now when Ray goes and sends data or encrypts data, it can all be digitally signed, and there's a proof of provenance of where that data originated, and it ties back to a public blockchain address, which is obviously very important when you want to have an auditable system.
And for those that have used any public blockchain, what's quite fascinating about this is the private key public key pairing. You can almost think of it like an email, like a username password. And so every patient here has a public key, public address. And so what we want to be able to do is just send the notes over to their public key, their public address, which is not owned by one of these large institutions, but it's actually owned by the patient. And also in terms of adding referrals. So because it's permissionless, any physician that wants to sign on that has an expertise in upper GI bleed, there's some experts that have done publications out of France, for example, they can actually participate in the network and come to add their clinical insights to this sort of, network, so to speak. So what we'll do is we'll go ahead and send this particular encounter now to the patient. It'll pop up this. If you want to talk a little bit about the ID, Chris.
Yeah, so what's going on here is there's an emerging standard. So W3C, the World Wide Web Consortium, is a standards body that develops a lot of the standards for the web. One of those is they're the ones responsible for HTML, which is a standard that makes sure that all the different web browsers that we use are consistent, and the way that those web pages are coded up display in the same fashion. One of their standards, one of their many standards in decentralization, is called the DID standard, decentralized identity. And it's a universal way for systems and individuals to generate their own identity, their own identifier, and then use that across different systems. So in this demonstration today, what we're doing is we're using a decentralized identity based on Ethereum. So if you see in that address, it's DID and then ETHR, which stands for Ethereum. So, and then the next part of that is an Ethereum address, a public address. So what we're actually doing is we're saying, hey, this is a patient has given this doctor their DID, which happens to be an Ethereum address. And so when Ray clicks on OK, what's going on behind the scenes is that this doctor's system is looking up on the blockchain that address. There's a document that's stored effectively on the blockchain, and that document has public keys, it has signing keys, and it also has an address, a database address of where that patient can be, can receive messages or receive data. And so when Ray clicks the OK button, what's happening is that this system is going to create a peer-to-peer connection with that patient's database. It's going to be able to find the public key of that patient and encrypt the data so that only that patient can unencrypt it, can decrypt that data. So what's happened there, if I now switch across to my screen, I'm going to show you the patient's view. So on this screen, I am now a patient, and I'm going to do the same thing. So I'm going to sign in, and I'm signing in using my Ethereum account, and I click on the sign button. So again, this is doing the same process. It's using a signature based on my Ethereum key to unlock and to decrypt the data that's in my vault, but it also allows me to unencrypt the messages that have been received by me. So in this vault, we've got my public profile, which I've optionally decided to put my name in there. And then we've got my data and my inbox. So we can see here that I've got an inbox message. I've got one message here, and Ray has sent me my patient data. So this is working exactly as we intended. There's an encrypted message that's here, and if I click accept, this information will now be stored inside of my vault. So I've now claimed ownership of that data. There's still some provenance. It's still been signed by Ray. So there's still the ability for this data to be looked at and to be confirmed to say, hey, that data came from Ray or it came from another doctor. But it's now stored, encrypted, and I have complete agency and control over that data. So if I go into this health section and I click on the clinical impressions area, we can see here, this is the information that's come through. So there's the notes that Ray entered earlier. Behind the scenes, as I said, it's signed, and this data that's actually existing in the system is using the FHIR health standards. So if anybody is familiar with some of the health data standards, FHIR is one of the, I guess, leading standards for data. And so we're using this data standard to ensure that the information that's stored in these vaults and stored in this decrypted, decentralized system is interoperable with a lot of the existing healthcare systems out there. So we can provide those bridges between the centralized systems that exist today and unlocking that information, that data, into this new decentralized world. So I'm going to hand back to Ray now, who's going to now pretend to be a different doctor. And we're going to pass this patient record back to a different doctor.
Thanks, Chris. So you might want to, ask why are we doing this? Why are we moving all this data around? It's interesting because it's actually already happening. So this isn't a question of adoption or not, actually. The data is moving to the tune of hundreds of thousands and millions of transactions globally. Between physicians, between patients, between fax machines, between telephone calls, through SMS and WhatsApp and WeChat and iMessage. If you were to really sort of unveil what's going on here, and you were to talk to your physician friends, because there's so many centralized services, and there's not a way to connect with the various providers wherever we need them. What ends up happening is you just kind of grab the lowest hanging fruit, like, here's a messaging system, and you might have some folks, it'll encrypt it, they might password protect it. But what's interesting, at the core of what we're showing here, and what Chris has devised, and the integration of all this is actually encrypted at the base layer. And so, as we all know now, when we make a referral, care protocol, what I just showed was actually, it used to be called nth opinion. And the reason it was nth opinion is because we believed in nth number of opinions. Folks these days are going for a second opinion. They see a physician, they might get a second opinion. And then, if they see a specialist, maybe a third opinion. And then they're going online, and maybe they're searching on Amazon to get reviews on a medication. And then they're going to look at side effects on Google, a fourth opinion, a fifth opinion. And it gets a little bit out of hand. And so if you want to really support where the care is moving in terms of customer service and what patients are actually already doing, you definitely need systems to help them and enable them to move the data around so that they can actually seek their own care and not have a burden on their primary care provider, where every time one of these requests come in, we're going file print, or burning it to a CD with large stacks, entire staff who have very important things to do, but setting aside chunks of time to work on that one piece. And so what I'm going to show here is a completely separate EMR, that was developed in our community. Here it is. Okay, so this is a practitioner EMR, and we intentionally said practitioner because we also believe in a space that's not just physicians, but all care providers and what we can call compassionate healers, ancillary staff, the wellness space. Vancouver's quite big on the wellness space as well, but the West Coast, the Pacific Northwest. So in that health and wellness space, any practitioner or care provider or frontline worker for that can actually connect to this. So we'll go ahead and we'll connect.
While you're doing that, Ray, I just mentioned, so Dennis, you asked a good question about when connected to MetaMask, did it connect to the Ethereum address, and how come the MetaMask tab disappeared? So yeah, so what happened is the browser page was connected to MetaMask, and then effectively there was a message that was signed, and once that message is signed, the MetaMask window disappears, and the signature is effectively stored in the browser and is then available to developers to use to manage the encryption of the data.
So we see electronic medical record systems, vendors, telemedicine software, such as the one on the screen here, essentially give the option now to automatically populate these public addresses of the patients if they want quick and easy access to their data. And so what we have on the right here now is a completely different EMR system. This will be a Dr. Jason Fung. And let's just say this is going to be the GI specialist that's wants to look at that referral note from the family doctor regarding upper endoscopy. And so there's no note in here. And by the way, this is often typically the case. If you're going to a new provider for the first time that you got referred to by myself, like a dermatologist, the chart's empty. So what comes to you typically is a PDF, well, not to you, to the receiving physician, is typically a PDF that's not OCR'd. And it's not searchable. And then it might or might not be scanned in. It's quicker most of the time for the physician to just create a new chart. So that's typically what they do. But and that takes maybe 15 to 20 minutes. So rather than creating a new chart, Dr. Fong here is just going to request a sync. So we're going to go ahead and request that sync. And I'll pass it back to Chris there, because this is going to the patient now, right? So this saves a little bit of work because we can request a sync to the other doctor or to the patient now. And it's all signed, by the way. So it's immutable. That's what the ledger is, an immutable ledger. So it's not like you can tamper the work that was done.
Thanks, Ray. So now I'm still back in Serena as the patient, and you can see I've got 2 new inbox messages here. And in this particular instance, we're syncing 2 different types of data. So when I click on the accept button here, what's happening is this information that's being requested is from a different system. And so I, as a patient, actually need to also authorize myself to be able to access the other doctor's system that Ray's using, because it's truly decentralized. And again, so I need to create a signature so that I can encrypt data for Ray in that particular system. So I'll go ahead and click on that. So then now that data's been encrypted and sent, and we're going to send a little bit more data. We're going to send both encounters and the clinical impressions. So now we've done a real sync, and obviously in this example, we've only got one data record, but it could be hundreds, it could be thousands. It's a peer-to-peer connection. It's incredibly fast, and it's completely decentralized. So hopefully, if we switch back across to Ray and he reloads his screen, he should see that note appear.
Demo day. So I purposely did not refresh because I just want to show how quickly this was actually happening. I'm going to hit refresh now, and Dr. Fong should receive the notes through this decentralized system here. And you know, what's interesting about all of this is actually the nature and the context of the note as well, because the patient and the physician can actually even make it more granular and choose which aspects within that FHIR protocol schema, basically a JSON schema, can select which aspects of it are necessary to share. Sometimes I don't want to share 1,000 records for, you know, one surgical procedure. I want what's relevant to make it easy on the receiving physician side. And so here what you see is what was created on one telemedicine clinic visit platform. Care Protocol moved to a patient vault, the Ikigai Vault, and then moved to this EMR now, a 22-year-old patient. Basically, you know, I get it, here to determine whether we should do an upper endoscopy or not. And so that's sort of the full loop there. And what's interesting about the data itself as well is what Chris was saying was, yes, it's in the FHIR schema, but also we do what's called a SOAP node, a subjective, objective assessment and plan. And you know, the majority of our clinical notes are created in this subjective, objective assessment and plan. And so what you have constantly are physicians actually already curating and or labeling the data. A subjective is what you tell me. So let's see here. You know, you drink a lot of alcohol. You've had 2 coughing or spells of bleeding through the mouth. Objective is objective data, numbers. So respiratory rate of 16, blood pressure, you know, 106/65, heart rate of 75. All objective data. Assessment is what you can call the diagnosis. And so if we're not quite sure, we might have a differential diagnosis of 2, one or the other. Or maybe, you know, in COVID, we're talking about an upper respiratory tract infection, or maybe COVID, a C19 or, you know, 465. So we actually label those constantly, consistently. Every patient we see, we're labeling and labeling and labeling. And the plan is basically also codified in a sense, you know, type in what we want to do. So what's currently happening with all that data? Right? Like, how is it being analyzed? How is it providing clinical insights? How do you move that to another provider? How do you run AI algorithms over it locally, you know, through a federated learning model, for example, such that the physician can have their own algorithm now? And so what we just showed today is almost the prerequisite, such that physicians now can have the tools of machine learning, for example, so that they can start to have their own algorithms locally on their vault. And whatever's trained locally on my EMR profile that I'm working on, and constantly curating and analyzing and moving around data, like a command center, which we are doing. Now that can actually turn into weights of an algorithm. And then we can move those weights along with all of the clinical notes that you just saw to the next physician, so that he can get my perspective as, you know, a family physician trained AI algorithm sent through the same system, by the way, encrypted, private key, public key. So, yeah.
Thanks, Ray. So let me jump back, and I'm going to now talk a little bit more about some of the technical detail. Again, Dennis, you've got a good question there that's come through. So how would prospective patients find doctors in a decentralized system? Aren't they all represented as arbitrary public keys? That's exactly right. They are all represented as arbitrary public keys. There's 2 key ways that can be achieved. So one is third parties can provide decentralized apps where doctors can go and register their key, or their public key, and their address, and sort of put their hand up and say, hey, I'm a doctor. That could include providing a verifiable credential, which validates that's been supplied by perhaps a trusted party like a government body. And that would be an example of, I guess, a centralized system creating a directory of all of those doctors and their keys. The other option is to use the blockchain itself. So there could be a trustless smart contract that's put up there that allows, with a contract address, which is a registry of doctors. And so a doctor could grab a verifiable credential, sign a piece of data that's added to that blockchain smart contract, and then that becomes a public registry of doctors that any decentralized app can look at. So there's actually a couple of different ways that can be achieved: the more traditional centralized way, and then I guess a newer decentralized fashion. And that's a really kind of emerging space. How to do that efficiently.
And let me just touch on that question as well. Is medicine used to be very paternalistic. The physician prescribes or pushes their treatments and their plans and the technologies that we're going to use. And that's transitioning now, in our era, to a pull method, where the patients look online for what they want and they ask the physician. So we went from a push to a pull method. And so actually, if this expands the way in which we think it will, because people do want their own privacy now, people do want to be able to, whether it's monetize their data or contribute their own data to research like breast cancer, or Alzheimer's, or COVID, for example, they're gonna do it if they want to do it. And so that's the pull model. And so what's interesting about this is that from a push model, you can have what are called, prescribed apps. So basically, if it's already a physician system where they have their panel of, let's say 1,600 patients, they're going to be rolling it out and plugging it in. And so they already have that therapeutic relationship with the patient and the provider. That would be the push model. So from the pull model is actually what Chris said. And, a couple of interesting things to look into. Germany just passed the Digital Healthcare Act, or in German, it's the DVG. And basically, this is a pool of apps, decentralized apps and systems and such, in which they're basically fast tracking various technologies and apps to be able to provide care. And so you're going to have all sorts of verification, credentialing systems in that ecosystem. In the United States, they had the 2016 was when it was signed into effect, the 21st Century Cures Act. And that deadline was supposed to come this November, but because we were in the middle of the COVID-19 pandemic, they gave one extension to April. And what the Cures Act essentially dictates is that all of these systems that we're using now throughout the United States and most likely beyond is that there needs to be innovation in healthcare that provides easy, effective, accessible controls to get their data, view their lab results. And so basically all vendors and all clinics and hospital providers will have sort of at a very base layer needs the ability to move around and share that data with their patients. So yeah.
Thanks, Ray. All right, let's keep moving because we're conscious of our time. So just looking a bit more at the technology behind the scenes. So as we saw, we're using the browser and MetaMask in this demo. There are other ways to interact with the blockchain and do things using mobile phone apps and other off-chain storage of keys and things like that. But for this example, that's what we're focusing on. So if we look at this diagram, what's going on here? This is showing, I guess, the process that we just sort of saw, but looking at what's going on under the hood. So the first step is we've got this web browser here, which, as I said, could be a mobile app or it's a web browser. And then what we do at the very beginning is we sign consent. So that MetaMask pop-up was to say, hey, I'm authorizing myself, and this is my decentralized identity. This is my Ethereum key, and I'm going to sign a consent message that corresponds to a decentralized document that exists on the blockchain. And that's my way of validating myself to the blockchain and connecting that, establishing that link between the browser and the blockchain. The next step is to sign another consent, which is actually providing the access to the database. So behind the scenes, we've actually got a CouchDB database on a server in the cloud, and that stores all of the encrypted data. And then we have an API, like a REST API, if you're familiar with REST as a protocol, a HTTP server. And it's providing a gateway. So what it's doing is it's saying, if somebody sends me a signed consent message where I can verify that that signature has come from an Ethereum address, I can send back a token to the web browser that gives consent to access parts of this particular encrypted database. And so what we're doing is we're actually bridging a decentralized world with Ethereum blockchain keys and decentralized identities and decentralized identity documents with traditional enterprise databases like CouchDB. And so once the web browser has this authorization key that's returned via this API, it can use that to read and write encrypted data from the database. And once it gets that data, it then has the private key to decrypt it. So what's going on here is that at no point is the database or any third party getting any access to that information. It's purely just a dumb sort of storage, I guess. The smarts is happening and all the encryption and decryption is happening inside the browser or inside the mobile phone app, which means this is much more secure than pretty much every other health system out there, because those health systems don't encrypt data at the end user level, they get encrypted at the server level, which means that the developers of these applications, the owners of these centralized health systems have access to all of that health data, which allows them to sort of use that as they see fit. So while it's a little bit complicated what's going on here, the net result of this is an incredibly secure system powered by blockchain. And the other key piece is that this is, it's peer-to-peer. So there's multiple of these different databases for every user. And so what we can facilitate is a peer-to-peer connection between these different databases, which is what we demonstrated when we shared those case notes. The information was being decrypted on the fly and then re-encrypted for the new recipient. If we have a look at CouchDB specifically, there's a few different databases that can be used. CouchDB is a very interesting one because it's designed for per user databases. It was actually a part of its architecture and design to allow it to be very efficient and well designed for databases for individual users, which is obviously what we're trying to achieve here. The other benefit is it was designed to be offline first. So if this data was existing offline, let's say it was on a mobile device and that device was offline, it's got a really smart synchronization and replication system that allows that data to kind of catch up when it comes back online. And that particular capability has made it very well suited for this asynchronous kind of world where different apps come online and come offline and different data is sort of available and not available. So that capability to do that synchronization and replication is incredibly useful to make this decentralized ecosystem work. It also has a very good live synchronization capability. So it's possible as a developer to subscribe and to be notified when data changes. So for example, I could be wanting to keep track of all of the information that is in a patient's vault about their knee surgery. So I want to track the word knee in any of the case notes. I could actually notify it in real time if there's a new case note that matches that. And there's lots of interesting ways that can be used. And one of those ways is actually just instant messaging. So the ability for that inbox to instantly send a message to say, hey, there's some data that you can claim, or that somebody's requesting some information. And obviously in the real-time fast world that we live in today, the ability to have that real-time notification is really critical. And if you look at a lot of the other solutions in this space, they're actually quite slow and clunky and don't have those sorts of capabilities. Finally, the last thing I'll kind of touch on here is that there's data schemas. So the ability for data to move around, if somebody's moving oranges around and somebody else is moving apples around, it's not going to work. Everybody has to be talking about an orange and know it's an orange, and talking about an apple and knowing it's an apple. So the FHIR data standard that I talked about in the healthcare space is that standard. It provides those definitions of different types of data structures and provides that common language that different systems can talk. And so built into this system is an implicit understanding of different schemas and different schema standards, which is what allows us to ensure that this data becomes interoperable as it moves between the patient and across into different healthcare systems. So if we look at this as a whole within this ecosystem, we have, I won't go into this too long because we're sort of a bit short on time, but fundamentally, we have a whole bunch of different actors and different pieces of technology that are playing nicely here together. We have in the middle well, in the middle here, we have a whole bunch of decentralized apps. So the Vault that I showed you was an example of a decentralized app. We've got EMRs, we've got the ability to have different apps for medical research and for AI, wearable apps. And then we have the patient being able to interact with this system. We've got the clinicians that can interact with the system. And then, very importantly, in my world, we've got the developers. So the developers are able to contribute open source code, machine learning AI models that can be trained consensually using the data stored across these different apps. We've got obviously the blockchain is sitting over here, and the data that we were talking about is actually off-chain data. So there's the off-chain storage of that data and the consent that's occurring in terms of providing access to those data storage options. And because the data is stored off-chain, it's obviously therefore we're not storing personally identifiable information on the blockchain, which is obviously very important. We're effectively providing all this capability adjacent to the blockchain, and just this information is being anchored by the blockchain.
And sorry,
so part of that is
there's a question here that's related to exactly what you just said, which is a great question. You know, the question was that about transaction fees on the Ethereum blockchain, and you know, when the actual blockchain itself gets congested, yeah, it's true. You've seen $2, $3, $5. You know, pre Ethereum 2.0, pre scaling, you got up to $20 per transaction fee. But you know, what's very innovative about the Ikigai network and the technology underlying it is that the actual signing of these transactions has no fee associated with it. One of the reasons of which is because the data itself is stored off chain. And so to actually generate these private key public keys and do a signing in and of itself does not tap the blockchain. And as such, there's no transaction fees. And you might want to paint some more color on that, Chris, or if that, you know, answers.
Yeah, that's a good point. Yeah, so there's no, you can actually sign data using an Ethereum key without incurring any cost. You can do that offline, so to speak. And if you create an Ethereum account, you can do that without actually transacting on the blockchain. So that's why this is really exciting, because it allows people to be using blockchain and not even really know that they're using it, but we're using that power and that capability behind the scenes. So then we only need to do a contract on the smart on the blockchain when we really have to, and we try and defer that as long as possible. But it allows us to, in that demo, we didn't do any transaction fees. There was nothing happening that incurred a cost on the blockchain, which is really exciting. That makes this a lot more accessible to developers and to end users.
And my digital signatures there were on the main net, so they weren't on like the Ropsten testnet or such. So yeah.
Yeah, excellent. So Ray, I'll hand it back to you. We've only got 8 minutes, so maybe we'll do a quick sort of outline, and if there's any further questions, we can answer those at the end.
Yeah, absolutely. So let's see here. Maybe what I'll do is on this particular slide here, we've pretty much already spoken about this, so we don't need to go into too much details, but the essence here is that the community that's evolving in and around this, which actually started back in February, which drew in many physicians, you know, to the tune of hundreds and hundreds of physicians and even thousands of individuals from, you know, the development community to the marketing and UI, UX development communities. What you see here are all the different pieces that add value to the network. So we had showed multiple decentralized apps or dApps. Chris had showed the developer part of that, in which anybody can contribute in a permissionless way. We showed care protocol as well, which is at the dApp layer as well, telemedicine, electronic medical record systems. But you know, the layer below that and the layer below that and the layer below that all also have much work to be done to move this entire, what we call the open health movement forward. So data scientists, for example, would be a huge value add to this, because that whole layer there of what you can call aggregators is now you have this encrypted data. Now that you have patients that have actually consented, have taken custody of their own data and said, now I want to contribute this to, and maybe you can flip it to the next slide here, Chris, and we'll go one more slide. Maybe we can come back to this. Maybe we want to contribute it to clinical trials, right? You have an individual with, let's say, Crohn's disease, or an individual that has medication side effects, or maybe an individual that extensively uses what we call, or I'm not sure who coined this, health over IP. It's kind of like voice over IP, but any interactions in healthcare over, internet protocols. So all of the interactions that we just showed you today would be considered health over IP, physician signatures, prescriptions, pharmacy, but also visits, telemedicine visits. And then the ability now, because we've had patients that have raised their hand that said, yes, these things are important to me. And my physician and I have spoken about this condition, and we've kind of hit a standstill. I have chronic pain and we don't know where else to go. What do we do? Well, I think that's the point at which the Ikigai Network and anyone that wants to plug in can say, hey, you know what? Clinicaltrials.gov has got 16 live trials on chronic pain, or perhaps new medications for acne, like 2% benzoyl peroxide face masks, or whatever it be. And boom, let's send them. They basically have consented now to say, I'm open for messaging. And you can have large research institutions like the National Institute of Health, or the National Institute of Aging, or the American Health Association, plug right in and send a message and say, yes, we are working on something that's similar to what you're experiencing. Maybe we can enroll in a clinical trial. So that data space and what you can do with it and how you can collaborate with patients and doctors is exciting. And if you want to just go one slide back, as an example of how that actually looks in an app would be sending patient results, sending messages. And as we all know, you can convert any of these alphanumerical strings into a QR code. That's how these public key addresses are easily scanned, and then you're able to send transactions, in the blockchain space. And so in this particular case, this is where things need to go. It is going. We're building it. We invite others to join to build it as well. Is the ability now, rather than me have printouts and one system with thousands of COVID-19 test results, their PCR scans, RNA of negatives and positives, and then having to, figure out who that is, how to call them, we can just send them a direct message through their QR code, shall they opt to consent into the system. So yeah, that's exactly about it.
And that allows us to also have medical profiles and things like that. There's a lot of things we can do in this sort of space. So another really good question there, Maria. So, and obviously everybody feel free to add any other questions just while we've got a few more minutes before we finish up. So Maria's asked the question, where exactly is my data as the patient being stored? Really good question. So if I jump back to this diagram, what's actually happening is the CouchDB database here, that's stored in the server, I guess, in the cloud. That is at its very core, it's a server address with as a database that's accessible through the web. So and that's storing the encrypted data. So what we normally do is an application will provide a default storage option for the users of that application. But what actually happens is that this decentralized identity document, this DID document, is where the address of that database lives. And the only way that DID document can change is by the private key of the Ethereum address that is attached to that DID document. So what that means is that the patient, the doctor, any user of this system can actually update their document and point to a different database. So they've got agency and control over where that data is stored. So it means that the system designed so the patient has control over where their data is stored, but also the doctor if they're using that system, or any other app, which is obviously true to the roots of what decentralization truly means. And then what happens is, as required, some of that data is sent down into the browser or into the mobile app. And there's another instance of the database here that decrypts that data and makes it available for developers in a decrypted fashion, which makes it actually usable. And that's done on demand as is required.
Yeah, we have another great question here by Zach, actually. And I can tell that this individual is well attuned to the blockchain space. So the question is, I'm interested in blockchain to reinvigorate the co-ops via more democratic decision-making and shareholding mechanisms similar to a DOA implementation. I think they refer to a DAO, a decentralized autonomous organization. I have no real experience in the space, but there's significant mention of healthcare co-ops in BC co-op law. Have you done thinking of blockchain use cases in helping leverage new healthcare co-ops? I imagine the wellness movement and indigenous healthcare providers could benefit. Great question. Absolutely. I think this is where the blockchain space will really shine moving forward. This concept of a DAO, or a decentralized autonomous organization, is that it really comes down to that grassroots movement, right? So this is created by physicians, created by patients and technologists for those same individuals. So you're absolutely right. They are the stakeholders, similar to how Ethereum and the security behind Ethereum, or the security behind Bitcoin, are the hodlers or the holders of all of these networks. It's in their best interest to make sure that it's secure, that decision making is moving the entire ecosystem in a similar and pointed direction. So I think what that might look like in this particular case is it's an evolving space of research, basically collective decision making on the blockchain, and how you can actually organize resources, organize resources in terms of capital, individuals, and development, and how do you incentivize that? And same goes with patients as well. How do you incentivize what you can call healthy behaviors? All of that is a hot topic of research and development right now. And so what that might look like in the Ikigai network is, if for those that wanted to join and really contribute, you probably would spin up a GitHub repo with a README file and start working out the mechanics of how that starts to look and move forward for the stakeholders in the network itself.
Yeah, and Dennis, again, another good question. How do you want to, if you want to get involved, what's the next step? So we've got a few links up here. So if you want to learn more about Ikigai network and the application of this technology in the healthcare sector, you can check out the Ikigai website, and there's the Medium posts there as well with a lot more information. If you're interested in the technology side, you can look at have a look at Verida, have a look at our website and our Medium post. There's also the documentation here, so you can actually go and have a look at the documentation. If you're a developer, you can actually have a play with that technology. In the sandbox, you can spin up your own decentralized app and walk through a process to do that, and to start managing and encrypting data for within these decentralized apps. And if anybody would like a copy of these notes, feel free to, my email address is just there. Feel free to send me an email, and I can flick those through to you as well.
Wow, guys, I think that is, if that's all you got, I mean, come on, we're waiting for more. No, I'm really excited. This is really a very exciting project, leading us forward in the future of open health, as you say, towards wellness, towards patient empowerment, which is really, really exciting to see. So I'm sure there's lots of people that would be interested in getting involved and more information. And so thank you very much again for presenting to us today this really exciting work that you've been doing. And we look forward to having an update from you and to hearing from you and staying in touch. So without further ado, unfortunately, we have to wrap it up for today because we've reached the top of our time. But yeah, sincere appreciation to you both for taking time out of what undoubtedly is a very busy time for you, especially, Ray, with everything going on with COVID-19 at the time, at this moment in time. So thanks again. We really appreciate it, and good luck with the project.
Thank you very much. Thank you for the opportunity. Great to chat and share what we're working on. Thank you very much.
Yeah, this was a great opportunity to share. Thanks very much.
Okay, thanks guys. Bye-bye.
Cheers.